Hi everyone and welcome to this video. In this video we'll be going through another worked example to help us get comfortable with logarithmic graphs. Okay, so I've got the question in front of me. It says plot the graphs of f of x equals log of x with base 3 and g of x equals to log of x with base 1 over 3, and then we need to use the graphs to determine for which values of x the following inequalities hold. Okay, so first thing I'm going to do is I'm going to draw these graphs. I'm going to draw it over here, draw my axis. Okay, that's my y-axis, that's my x-axis, and now I'm going to draw f of x first. So I can see here my base, 3 is greater than 1, and when my base is greater than 1, I'm going to have this increasing function. Okay, and let me just label that. This is f of x, and then I'm also going to draw in green, I'm going to draw g of x. So as I can see here the base 1 over 3 is less than 1, so that means my log graph is going to have this decreasing shape. Okay, right, so one thing I want to point out when we begin, we have f of x, the base is 3, and g of x, the base is a third. A third is of course the inverse of 3. So what we have is that f x and g of x are reflections of each other about the x-axis. Okay, you should know this when you have the base a and then another graph. So we have a log of a of x and the graph log of 1 over a of x with the same a, and then these two graphs are reflections of each other about the x-axis, and that is exactly what we have in this case. Okay, so I'm just noting that out. It might not be useful, we'll see, but let's go on and answer the questions. Okay, so A says we want the values of x for which f of x is less than or equal to 3. So the best thing to do first is to find where f of x equals 3. Right, so what's the x value where that is the case? So we're going to have f of x, which is equal to log base 3 of x equals 3. So that implies that by the definition of logs, 3 to the power of 3 must equal x. Okay, so 3 to the power of 3 equals x, which implies that x, so that's 3 to the power of 3, so that's going to be 27. Right, so we have the point on the graph of f of x, 27, 3. So let's mark that off. Okay, so I'm going to say that somewhere here. That's the point 27, 3. So this would be 27 here, and that would be 3. It's not the most accurate of drawing, I concede, but nonetheless, as long as you draw it roughly accurately with the correct coordinates, that is fine. Okay, so for which x values is the graph of f of x below 3? So we can see here, here's our y value of 3. So where is the graph of x lower, below this line? And that is, of course, we can see everywhere to the left of this vertical line here. We can see that the graph of f of x is below the value of y is equal to 3. So what are the x values that correspond to this? Here we can see this is where x is equal to 27. So wherever x is less than 27, the graph of f of x is below y is equal to 3. Okay, and that's it. So here we're going to have the answer to A is x is less than or equal to 27. But that's not absolutely correct. We also need to specify greater than 0. Right? Because where x is less than or equal to 0, that side of the graph is not defined. So we have to be precise. Okay. So for A, that is, the original question was less than or equal to 3, right? And we have our answer over here. Now B, where f of x is less than or equal to minus 3. So again, we're going to determine where f of x is first equal to minus 3. So that we're going to have log 3x, which is f of x is equal to minus 3. So that implies that 3 to the minus 3 must equal x. So 3 to the minus 3 equals x. And that implies that x is equal to 1 over 3 to the 3, which is 1 over 27. Okay, so here we have the point x value, of minus of 127, right? And the y value of minus 3. So where's that? The x value of 127 is about here, very close to the x-axis. Okay, and then minus 3, we can say that's about somewhere here. So I just need to redraw this graph because the graph isn't quite accurate enough. Okay, there we go. So now I have this point here, which is the point 1 over 27 and minus 3. Right, so where is the graph of f of x less than this minus 3? So that is clearly in this little section here, right, where x is in that value. So that is where x is less than 1 over 27. So what we have is that we're looking for this, and the answer will be x is less than or equal to 1 over 27, but again greater than 0. Okay, so it's just in this little space here is where the inequality of B is satisfied. Okay, let us continue. C, so now we're working with g of x, and it's going to be a very similar situation. G of x less than or equal to 3. Now we can see here, we already have the graph of g of x, and we already have the line y is equal to 3. So here, at this point, is where g of x cuts the line y is equal to 3, and we can see that for all x values to the right or greater than this x value here, that is where g of x is less than or equal to 3. In fact, a g of x equals 3 at x value 1 over 27. So again, forgive me, not the most accurate of drawing, but this is all in the same line here. So we can prove that algebraically. If we go g of 1 over 27, that's going to equal log base 1 over 3 of 1 over 27, right? So that implies that 1 over 3 to the power of this value, g over 1 over 27, is equal to 1 over 27. So I'm just going to use y notation to make it easier. So y is equal to, that's going to be 3. Right, that's easy to see. So, which is exactly this point here. So we have 1 over 27, y is equal to 3. So we can see that any x value this way of this vertical line will give us the required inequality g of x is below y over y is equal to 3. Okay, so the answer here is x is greater than 1 over 27. Okay, now for D, okay, we want g of x less than or equal to minus 3, right? Where's minus 3? Minus 3 is over here, right? So at this point here, we want all the x values that's going to give us here, where g of x is less than y is equal to minus 3. And I'm not going to go through all the details again, but you can kind of see, since these graphs are reflections of each other, it is at this point x is equal to 27, where g of x equals minus 3. So this is the point here, 27 minus 3. So to answer this question, we want x is greater than or equal to 27, and that will give us g of x below, less than or equal to minus 3. Okay, the last question E, we want where f of x multiplied by g of x is less than 0. Okay, so when you got an inequality like this, two values multiplied by each other must give less than 0. So negative, we need one to be negative and one to be positive. Okay, we can't have both negative, we can't have both positive. Now if we look at this graph, we can see it seems that everywhere in the domain of course being x is greater than 0, everywhere we have one graph which is above and one graph which is below. And here on this side, one graph which is above, one graph which is below. So we always have one value negative and one value positive, except for one point, and that is exactly this point here where they intersect, because at that point they are both equal to 0, right? So what we have here is that x is greater than 0, but x is not equal to 1, because at x is equal to 1, this is going to equal 0, that's going to equal 0, and this whole thing will equal 0. But of course we're not looking for less than or equal to, we're looking for strictly less than, so we cannot include this value of 1. That's why we specify x is not equal to 1. Otherwise we can see that any other value in this whole section here is going to work. Okay, and that is the answer for question E, and that does bring me to the end of this video.